Hi folks, welcome to Physics with Captain Rod here. I'm making this video to help you out with your homework a little bit. I'm doing this at request. So I'm going to talk about a few of these, 5, 6, 7, maybe 8 and 9 as well. So in number 5, right, it says a jet with a certain mass has an engine exhaust equal to 59,100 newtons. That's the one on the homework I'm reading. Your number will probably be different than that. Part A, where it says find the acceleration at takeoff. So that's a Newton's second law problem. So for part A, I'll just write out force equals mass times acceleration. They give you a force, they give you a mass, so then you just find the acceleration from that. Part B, where it says what is the speed after it accelerates for 6 seconds. Yours might be a different value, but mine says 6 seconds. That's a study of motions. That's like a Unit 1 type question. So for part B, what I would do is draw a velocity graph. Right? And this jet presumably started from rest, and it accelerated, so the velocity increased, right, for some time, which is given in the problem. So that would be a given value. The slope of this line is equal to the acceleration, which we know if we did part A, and that's equal to change in v over change in t. Right, so in my graph here, this is my change in t, the horizontal distance. The vertical distance here, that's my change in v, so rise over run. So the acceleration is given. The delta t here was given. Calculate the delta v here, and that'll tell you how fast it was going. So once you know that, the height here would now be a known value, and the time here is also a known value. So to answer part C, where it says how far, that's a delta x, or change in x, and that can be found from the area under the curve here, which is 1/2 times whatever you got for t times whatever you got for the change in v here. Right? So that's pretty much how to do part 5, right? Question 6 here. Let's see, let me get a new sheet. All right, so in 6 it says the maximum acceleration of a fist was measured to be 2950 meter per second squared. At least that's what mine says. Yours probably says a different value. Part A, it says if the mass of the fist is 0.6 kilograms, what is the force? So that's a Newton's second law problem. So for part A, you just write out force equals mass times acceleration. They gave you a mass, they gave you an acceleration, calculate the force. Part B is a conceptual question, right? And if I draw a picture, fist here hitting a block, the force that the fist exerts on the block is this way. At the same time, the block exerts a force back on the fist, opposite direction. That's Newton's third law. Forces always appear pairs, same magnitude, opposite direction. So part B is a conceptual question. Think about this picture and your answer for part A. All right, let's talk about number 7. Let me get a new deal here. All right. In number 7, it says a sprinter with a mass of 84 kilograms accelerates 0 to 6 meters per second in 2 seconds. Now, your numbers will probably be different than the one I'm looking at, but the important thing to realize is that you've been given a mass, you've been given an initial velocity, a final velocity, and a change in time. These are all values given. So part A says, what is the runner's acceleration? Well, acceleration is equal to change in v over change in t. The change in v is equal to v final minus v initial. So this is just put in these values, get a number out. For part B, where it says what is the net force acting on the runner? So once you have the acceleration, for part B, we just write out force equals mass times acceleration. Mass was given in the problem. Acceleration is what you found in part A. Right. Question C, 7C. How far does the sprinter go in 2 seconds? So this sprinter, they're starting here, and then the motion diagram, they're accelerating, moving faster and faster and faster. If I were to draw a velocity graph, that might look something like this. Velocity against time. They started from rest, I know this because the first number in the given in the problem is 0 meter per second. They accelerated to some higher value here. In my example, it was 6 meter per second, but in yours it'll be a different value. It took a certain time. In my example, it's 2 seconds, but in yours it'll probably be a different value. As far as getting how far they went, that's their displacement, their delta x, and that's going to be the area under this curve here, that rectangular area. That's going to be 1/2 times 2 seconds times 6 meter per second. Again, this is in my example. Yours will be different depending on the different numbers. So that should get you through number 7. I'm going to go ahead and talk about one more here. Number 8. So a baseball is being caught. It goes from 42 to 0 in 0.004 seconds. So they've given a V initial, they've given a V final, and they've given me a delta t. So start by calculating the acceleration, which is change in V over change in t. If you're having trouble getting it to take it, let's see. It could be because of the plus and minus signs. So actually on the sheet it says indicate the direction with the sign of your answer. So if you're decreasing in velocity, your change in velocity is negative, and therefore your acceleration is a negative number. So shouldn't have too much trouble with part A. Part B, where it says what is the acceleration in G's. So all right, the term G's, this is kind of slang in physics. G is about 9.8 meter per second squared. So an acceleration of 19.6 meter per second squared, you see how it's double the 9.8? That's referred to as a 2g acceleration. 30 meter per second squared would be a 3g acceleration, give or take. 50 meter per second squared would be a 5g acceleration. Basically, take your answer to A, divide it by 9.8. That'll tell you how many g's you have in acceleration. And then for part B, apply Newton's second law when it says what is the size of the force acting on it. So write out force equals mass times acceleration. Mass was given in the problem, and acceleration is what you calculated in part A. So that should get you, a pretty good start on those problems. And again, please be sure and post any questions you have in the forum, because the more interaction we have, the better. And if you're really struggling, please email me, and I'll be happy to make more videos helping you out with the homework. All right, have a great day.